Hey everyone, welcome to day 10 of our derivatives and integrals challenge. So for the first part, we're going to differentiate this f of x function. We have the ln of this entire thing, so we're going to use the chain rule, right? So our derivative function f prime of x is going to be, the derivative of ln is 1 over that whole thing, so 1 over x squared plus e to the sine x times, by the chain rule, the derivative of this expression inside the bracket, so that'll be 2x plus the derivative of e to the power of a function is the derivative of that function, i.e. the derivative of sine x, which is cos x, and then times, as it was, e to the sine x, and we can just multiply that through. And so this one's not going to be too long of a solution. We'll have 2x plus cos x, e to the sine x, all over x squared plus e to the sine x. And that was pretty quick. Now, the second one is the one I'm more kind of excited about. We have the integral of e to the x times sine of x dx, and we're going to use the integration by parts approach. So when we integrate by parts, we're always tasked with first making wise choices for our u and dv portions. Okay. Now, I want to show you what happens if you do it one particular way. At the start, you kind of have your options to choose from, because integrating and differentiating e to the x is no harder one way or another. The integral and derivative of e to the x are just e to the x. Super straightforward. The derivative of sine x is cos x. The integral of sine x is negative cos x. Again, there's no one way that's a lot easier than the other. And so since there's no real obvious pathway forward at the start, let's just make a choice and go with it. I'm going to say e to the x is going to be u, which means du is going to be e to the x dx, and that means that dv is going to be sine x dx, and v will be the antiderivative, that'll be negative cos x. And now we'll apply our integration by parts formula, and so this integral we can write as uv, that means negative e to the x cos x, minus the integral of v du. This negative will interact with that negative to make it a plus, and so we'll have the integral of e to the x cos x dx, okay? And at this stage, I want to take a second and kind of pause here. We're going to go one way, and we'll see that it doesn't quite get us to where we want to go. Here's how that works. If you make, because now we have a new integral, and we're going to use integrating by parts to grapple with this one, okay? So we need to make new choices for u and dv respectively. So I'll show you what happens if you do the wrong way, okay? If you make your dv e to the x dx, then your v is just cos x. That's not what I meant. That is absolutely not what I meant. Then your v is the antiderivative of e to the x, which is e to the x, rather. Your u is cos x, and then your du, the derivative of cos x, is negative sine x dx. Okay, now I want you to see what happens here. That means that this entire integral, right, this is the one we're after all, is going to be equal to negative e to the x cos x, because this stuff is unchanged, plus the integral of, we're going to treat this guy by parts. So we'll have this guy using this formula, meaning u times v, meaning e to the x cos x, minus the integral of v du. This negative will interact with that negative, and we'll make it a plus the integral of sine x dx times e to the x, or if you'd rather, e to the x sine x dx. And now look what happens. We have this integral is equal to, these two terms are equal in magnitude, opposite in sign, so these guys cancel out. And so our result is not wrong, but all we found was that this is equal to that. Not all that surprising. Not also not all that useful is my point, okay? So there's nothing wrong with that. Again, it just doesn't get you anywhere useful. So let's kind of scratch that out. And all that tells us is that we need to make smarter choices for our u and dv. Okay? So let's regroup. Let's go the other way. okay, because there's only really two options. The first time we let, oh no, what did we just do? The last time I had set dv to be e to the x, so this time I'm going to make dv cos x dx, which will mean that v is the antiderivative of dv. The antiderivative of cos x is sine x. And I'll make u be e to the x, which makes du e to the x dx, okay? Now, with these new choices in mind, let's try this again. So this result will keep going. We'll have negative e to the x cos x, right? Plus this integral we're going to treat by parts, right? And so I like to put these inside of square brackets to remind myself what I'm doing. So this by parts is going to mean u times v, which means e to the x times sine x, minus the integral of v du, v du. So that'll mean, whoopsies, v du is going to mean e to the x dx times sine x, or if you'd rather, e to the x sine x dx, okay? And now, I'm not sure how you feel about this, but I'll point out the fact that this integral we have showing up again here, but with a negative in front of it. And these two terms don't cancel out at all, not in the way that they did the first go around. And so here's how that works. I'll remind you that this integral is what we're after all along. So I'm going to write it on the left-hand side. The integral of e to the x sine x dx is equal to, and it's going to be this right-hand side. Okay, so we'll have negative e to the x cos x plus e to the x sine x minus, once more, the integral of e to the x sine x dx, okay? So these two integrals are exactly the same, but this one is being subtracted, has a negative in front of it. That means that the same way that we could do that with x's using algebra, the way you've done for years now, we can add this integral on both sides. And so let's go ahead and do that. That means these guys cancel out, right? Equal magnitude, opposite in sign. Do the same thing on both sides, right? They're gone on the right-hand side. Here, we now have two of the same, and so you can say we have two of the integral e to the x sine x dx, right? Equals these two terms. I'll change the order just because this one is positive, this one's negative. So I'll write this as e to the x sine x minus e to the x cos x. There we go. And now, 2 times this integral that we're after all, is equal to this expression. All we have to do to get this integral all by itself, to get rid of the 2, is, as you know, divide both sides by 2. And so that brings us to our final step of writing our result, e to the x sine x dx being integrated results in e to the x sine x minus e to the x cos x all over 2. We can factor out an e to the x from both terms in that numerator. And so our final result is going to read that this integral is equal to e to the x times sine x minus cos x all over 2. And we are done. I really like this one because you kind of see that if you make unwise choices for your u and dv, it's not that you get an incorrect statement, but you get an unuseful statement. You get a statement that is not helpful to you at all. And so then you can kind of revamp and rethink your choices for u and dv respectively, go through with that, and then you get the same integral on both sides, move them both on one side, and then just a tiny bit of algebra in a way that you're maybe not used to, but that works all the same, and you get a nice, tidy result in the end. So, bit of a long integral, but I hope this helps. Thanks for watching, and please like and subscribe.